Following the finalization of the Laplace transform of e to the power of t identified in the previous video being 1 over s minus 1, let us try to evaluate the Laplace transform of e to the power of negative 3 and Laplace transform of e to the power of 5t. Of course, in the previous video, you might want to review that. In identifying the Laplace transform of this expression, or e to the power of t, we follow the formula, the integral from 0 to infinity of e to the power of negative st, and then here you have your f of t, which is e to the power t, and then dt. We're able to combine this, coming up with different forms and strategies that resulted this form. Let's see if we can also generalize a certain form as we talk about the Laplace transform of e to the power to any alpha t, where alpha is any arbitrary constant. Let's look at the Laplace transform of e to the power of negative 3t. Following the formula here, this is equal to the integral from 0 to infinity of e to the power of negative st, then times e to the power of negative 3t, it's negative 3t, dt. The same thing, we can combine this. You have the Laplace, the integral from 0 to infinity of using the laws of exponents, e to the power of negative st minus a 3t dt. Okay? Which also be written as by factoring t and negative on both sides, e to the power of negative. So factoring the negative first, s plus the 3, you factor t here as well. We're doing this so that we could actually integrate this looking into the correct du to be added here. So let's skip this and let's talk about it later. Now, we need to come up with a certain du. Following this, we have negative of s plus the 3t. Take note that we also factored negative here because in the previous video, it allows us to reciprocate this exponentiation, making the exponent positive. Now, to make this e to the u du, our du must also be the first derivative of your exponent. The derivative, if your u is negative of s plus 3, you have here t, okay? As you take its du with respect to t, okay? So this would be a constant. You will have here the negative of s plus 3. This is what you need to add for dt to integrate this. So basically, that's again what you need to add here. Sorry for that. Okay. So this is, you will be adding or multiplying a negative of s plus 3 dt. To neutralize this, of course, we are going to divide this by negative as well, 1 over s plus 3. Okay, it's okay for you to already place the negative sign here because the negative of negative will cancel themselves with s plus 3 and s plus 3 here. We're doing this so that we can actually generate our solution more efficiently. So we'll have here negative 1 s plus 3, and now this could be integrated itself e to the power of negative s plus 3 times t. But this should be integrated from 0 to infinity. Okay, so we rewrite negative, sorry for that. We rewrite this expression s plus 3 into this form 1 over e, making the exponent positive like this. Okay, by the loss of exponent. We're doing this as we integrate it from 0 to infinity because as t approaches to infinity, this expression, since the exponent will become approach negative, this expression will approach to 0. Okay? As this will approach to 0, no matter what the value of this, as t approaches infinity, this entire expression will be 0 on the first substitution. So you will have here 0 for the infinity. But for the 0, you will have here minus negative 1 over s plus 3, 1 over e to the power of s plus 3t. But the t here will become 0. Okay? If you make it 0, you would know that the entire denominator here would become e to the power of 0 equal to 1. Hence, you'll have 0, double negative property plus 1 over s plus 3. And you will have here times 1 as it is 1 over 1. Hence, the Laplace transform of e to the power of negative 3t is 1 over s plus 3. We will try to generalize later using this expression and the expression already presented in the previous video. Okay? Hopefully the space will be enough here for the Laplace transform of e to the 5t. So this would be equal to the same formula, the integral of 0 to infinity of e to the power of negative st times your f of t, which is e to the power of 5t dt. Similar as earlier, we can combine them this two according to the laws of exponents. You have the integral of 0 to infinity e to the power of minus st plus 5t dt. Okay? We can again factor the negative and t on both sides. You have negative, so this will become s. The plus 5 will become minus 5 t dt. So that we could come up with our correct du. So if u, sorry for that, if u is equal to negative of s minus 5 and then t, the du with respect to t is negative s minus 5 dt. Okay? So we need to add, again, just like what happened earlier, negative 1 minus s minus 5. To neutralize the term, we are going to add here minus 5t, this term, negative s minus 5. Okay? So that as we multiply that, it will be cancelled and the negative will be cancelled here. It's just the same as the previously written equation. So this will leave us into a form, negative 1 over s minus 5 times the integral of this, which is e to the power of negative s minus 5t from 0 to infinity. Just like what happened earlier here, this one, as t approaches to 0, this expression, because this will be applying the law of negative exponent, will become a denominator of a rational expression. As t approaches to infinity, the entire expression will be approaching to 0. So the first term would be 0 for your infinity here. So 0 minus, then you will have negative 1 over s minus 5. Then you have here 1 over e to the power of positive s minus 5 times 0. This is minus 5. So this will become 1 over 1. So you will have here double negative property, positive 1 over s minus 5. This is your Laplace transformation or transform of e to the power of 5t. Okay? Now, as mentioned earlier, we are going to generalize for all forms like this. As you can see, for an exponent with 5t, you will have s minus 5. Earlier, if it's negative, you have plus 3 here. And in our previously formed idea in the previous video, you can also write 1 here. So you have s minus 1. So generally, you can write it like this. For the Laplace transform of any expression or function e to the power of alpha t, where alpha is any arbitrary constant, this is equal to 1 over s minus alpha. As you can see, again, this is 1, so that's why s minus 1. You have here 5, so s minus 5. But if you have negative 3, so s minus negative 3 is plus 3. So this can be used in further idea if you have more examples later on. But generally, these are the results for the Laplace transform of e to the power of 5t and the Laplace transform of e to the power of negative 3t. Thank you very much for watching.